Okay, so on this one, the numerator is in degree 3, so we should divide the denominator. Alright, so to expand the denominator is say 3x, 3x here, sorry, 3 plus x, q plus x squared. Okay, so this is, if we expand it, we're going to come up with x cubed plus 2x, x cubed plus 3x squared plus 2x plus 6. Okay, so that's the expansion. So we divide, sorry, I need to do this like this, x cubed plus 2x, the one which is on top here, minus 11 over dividing x cubed, which is the function which is this one, x cubed plus 3x squared plus 2x plus 6. So to divide, the easiest way I can do it is to do it like this, x cubed plus 0x squared. I'm taking out coefficients plus 2x minus 11. Then um, I subtract x cubed plus 3x squared. Those are the same functions. This one is this one here. This one is this one here. 3x squared plus 2x plus 6. So this will give me minus 3x squared minus 3x squared minus 7c. So to put it in partial fraction, it's actually going to the function rearranged, it will be f of x is equivalent to 1 plus this function that I got here, this one, minus 3x squared minus 17 all over x plus 3 q plus x squared. So that is now in this way. It is now it is now in a form that I'm able to expand, because now this one is proper fraction. Okay, so I'm going to write in partial fraction form. Right, in partial fraction form. So in partial fraction form, minus 3x squared minus 17 all over x plus 3 x squared plus 4 is going to be in the form a over x plus 3 plus bx plus c over x squared plus 2. Then if I multiply through by this one, multiply through by x plus 3 x squared plus 4. That's what I'm going to do here. So if I expand, if I multiply 3, what I'm going to come up with is, it will clear out this side. So it means this side, it will cancel out. Our remain is minus 3x squared minus 7c. Okay, this is equivalent to the other side is a x squared plus c plus bx plus c x plus 3 plus 3. Then we expand to expand this one here. It will give me a x squared plus 2x 2x. Then to expand this one, it will give me expand this one. It's going to give me b x squared plus 3bx plus cx plus 3c. Okay, so after expanding all this, then I can actually add this function and this function here. It means I'll have terms in x squared. If I add terms in x squared here, it will be a plus b x squared. Then terms in x I do not have any, so I will have this one here, which is 3b plus 3b plus c x. Okay, then constant term after this one in this one, which is going to give me cx plus 3c. Okay, then alright, no. It will not give me cx plus 3c. Terms in constant, it will give me or rather cx had already considered cx. So the only constant term that I have is this one, is 3c. Alright, but no, the other constant term that I have is this one, ca. I'm sorry for that. It's plus ca plus 3c. That's okay. So what I can do now, I'm now comparing. I'm now going to, because remember the overall equation is minus 3x minus 7 is equivalent to this expression that I have here, a plus b x squared plus 3b plus c x plus ca plus 3c. So if I equate coefficients, terms in x squared, will give me terms in x squared will give me minus 3 is equal to a plus b. Alright, then terms in x will give me 3b plus c is equal to 0. 3b plus c is equivalent to 0. Okay, then constant term I'll get 2a plus 3c is equal to minus 10 2a plus 3c is equal to minus 10. Alright, so that's those are the three equations that I have. 1, 2, 3. Those are the three equations. So I'm going to solve them simultaneously. So to solve them simultaneously, if I'm going to from equation number 2, so I'll take equation number 2. C is equal to minus 3b from 2 to c C is equivalent to minus 3B. Okay? And I. So I'll substitute 2 into 3. Substitute 2 into 3. Now putting 2, that's one, the one I got here, into 3. What do I get? I'm going to get 2A plus 3, open bracket, minus 3B, is equal to minus 17. Then it will give me 2A minus 9B is equal to minus 17. Okay, so that's what I have here. So this becomes equation number 4. Okay, let me put it in this. Okay. So I'm going to say from 1. So I'm going to say 1 because number 1 into 4. So because number 1 into 4, I'm going to get 2 minus 3 minus B is minus 9B is equal to minus 17. So if I solve it out, I'll get minus 6 minus 11B is equivalent to minus 17, which gives me if I take 60 side minus 11B is equal to negative 7. So B is equivalent to 1. And if I solve out, if I substitute B is equals to 1, I'm going to get A is equal to minus 3 minus 1, which is A is equal to minus 4. Then C also is equal to minus 3, 1, and V. Then I get minus 3. Then the final partial fraction is going to be final. It's going to be f of x is equivalent to 1 plus the value of b minus 4 over x plus 3, okay, plus dx plus c, so my b is 1, so x here, 1x, okay, let me call it 1x minus 3, which is the value of c over x squared plus 3. So this is the final partial fraction that I come out. Then the part B, we are going to obtain the expansion of f of x. Let me highlight. Obtain the expansion of f of x in the ascending powers of x up to including the term in x squared. So what I'm simply going to do is I'll rewrite it. F of x is equivalent to 1 minus 4 over x plus 3 plus x minus 3 over x squared plus 2. Okay, so this is the term that I have. So I'll do first with term 1. Term 1. This is term 1. Term 1. 1. Term 2. 2. Term 3. So I want to expand them separately up to the powers in x squared. Okay. So to expand them, I'll start with term 1. So term 1 is constant. So term 1 gets this one, the constant. So it's equal to 1. Okay. Then term 2. Term 2 now is 4. Term 2. Term 2. Okay. It's negative 4 over x plus 3 is equivalent to. So I expand it minus. Okay. So I say 4 over 3 outside of the bracket, then 1 plus x over 3 x plus x. Then this becomes equivalent to minus 4 over 3, this one here, okay, all over x plus 3 over, 1 plus x and 1 plus x over 3 to the power of negative 1. So to expand it 1 plus y to the power of negative 1. It will give me 1 minus y plus 5. Then if I take my y to be x over 3, it means x plus, it means 1 plus x, 1 plus x over 3 to the power of negative 1 is equal to 1 plus x over 3 plus x squared over 9. Alright, that's what I mean. So if I multiply by, because I'm taking the experiment, if I multiply by minus 4, because I'm now taking this bit because I've expanded this one. So I have minus 4 over 3, okay, 1 minus x over 3 plus x squared over 9, okay. Then this will give me minus 4 over 3 plus 4x over 9 minus 4x squared over 27. So that's term number 2. So term number 2 is done. So we go on to term number 3, which is x minus 3 over x squared plus 2. I'm going to expand that one. So this will give me x minus 3 over 2, open bracket, 1 plus x squared all over 2. Okay? Then to expand this one, I can actually take I can take this one here. I can take it out here to get 1 out x minus 3. Alright. Then this one here is 1 plus x squared all over 2 to the power of minus 1. Okay. Because remember, this one, if I multiply it like that, it means this one is flipping. But instead of it flipping, I can introduce negative 1. Alright. So the expansion of this one now expansion of expand 1 plus x squared over q to the power of -1. Okay, so this will expand according to binomial expansion 1 minus x squared over 2 plus we don't need other terms. Actually, we only need that term up to the third term. We only divide it like that. Okay, so I'm going to join up this one here. That's the expansion that I need. Okay. So I'll multiply. Mm, mm. Multiply. Okay. So if I multiply half of x plus 3, then the expansion 1 minus x squared over 2. Okay. So if I multiply that, I'm going to get half x minus 3 over 2 minus a quarter of x cubed plus 3 over 4, 4x squared. Okay. Then if I only need up to the x squared, so I'll have minus 3 over 2 plus half x plus 3 over 4 x squared. Alright, that's okay. So I'll add up all the three terms. The first term that I had was the constant term, which is 1. That's a constant term, which is 1. Yeah. The second term that I had in expansion, alright, was this one here. This was the second term that I expanded up to x squared. Then the third term, let me get right, third term, term 3, term 3, okay? Term 3 is well. Then third term, it comes up to, okay. So what I'm going to do is to add everything. So to add everything, this is the first term was 1 plus the second term equals second term minus 4 over 3 plus 4x over 9 minus 4 over 27 x squared. Okay, the third term minus 3 over 2 plus half x plus 3 over 4 x squared. Okay, then collect like in constant terms 1 minus 4 over 3 minus 3 over 2. Okay, terms in x squared 4 over 9 x terms in x squared plus half x minus terms in x squared 4 over 27 x squared plus 3 over 4 x squared. Okay, then f of x is equivalent to minus 11 over 6 plus 17 over 18 x plus 65,108 x squared. So this is x times 1. So thank you.